let's switch to configuration. So a configuration needs to be created. You can click on the new configuration button to create a new configuration and further adjust the settings. For this system, I already created a configuration. And once you create the configuration, we'll also add the information on the table placement. So this is the standard information we'll provide by an SAP node, which is relevant for a scale-out system with 3 slave nodes or more. So again, those are the standard values we added to the table placement. You further have options to create some location groups, which is a collection of nodes assigned to a location group name. And you can add this location group, if you like, to the location section listed in the table placement. We also have the option on a leading table, which would specify the leading table within a table group to be recognized as the table, to specify the number of partitions, and the number of partitions will be adjusted to the remaining tables also same to the same table group. At this time, I'd like to stay with the current configuration of table placement. Once it's being edited, you can make it activate, but it's in active state already. So let's move on and generate a new plan within the redistribution tab. Let's hit the generate button. We use the profile DDO split, redistribute and balance, which gives you the option to also create additional partitions. We also have other profiles in here, which is just the redistribution and balance algorithm within DDO. So in that case, we do not create or remove partitions to tables. And we also have a HANA algorithm included, which will be provided by the HANA team responsible for the HANA Studio optimized table distribution. The list of algorithms or profiles will be further adjusted as we move on to newer versions of DDO. In this scenario, I'd like to focus on the DDO split, redistribution, and balance algorithm. So that's the algorithm capable to add or remove partitions to tables created with the partition spec. Let's pick the correct configuration. Let's go after a database schema, SAP BW, and just stay there, as we have further options to also only work on the granularity of a table group or specify group types. So at this moment, we just select the database schema and let the plan being generated. The other options on stop condition, on distribution, and number of partitions will stay unchanged. As we have a distribution, the option for a more data warehousing type of distribution or a more OLTP type of distribution. But as we have a BW system to be analyzed, so we'll focus on the data warehousing distribution placement strategy. So let's go ahead and generate the plan. The blue moving circle is the identifier that the plan is in the process to be generated. The plan generation successfully completed, so we now have a plan 108 we can select on and get the details out of the identified reorg steps to be performed on the system to have a first balancing option in place. Let's select the plan. On the lower part of the screen, you see the different plan steps. So those are the steps relevant and identified by the algorithms to balance the memory allocation within this given scale-out environment. So you get the information on the schema, on the table name, on the current partitioning, and the recommended and proposed new partitioning specification. So in that case, this table will be altered to become a hash 3 partition table. Having said that, so new partitions need to be created, and within this plan step tab, we only visualize the relevant steps to be adjusted to the system. So partition 1 in this case has been identified to stay in the current location of the node, and we're just adding more partitions to the environment. On the new host section, you see which host the certain partition will be created on. So that's going to be a long list because we optimized, or we created a generation plan for the full BW schema. But before getting down to all the details, I'd like to visualize the simulation to make yourself more familiar with the option to really use the tool to simulate the distribution and then further optimize the proposals being generated by the algorithm. So on the screen, we're comparing the actual with the simulated memory allocation, where the actual is being listed within the blue bars and the calculated distribution is listed by the green bar. So what you can see is we had an overload situation on node number 1. We're coming from 53% allocation based on the first algorithm. On the first algorithm execution, we moved the allocation down to 46%. We increased the memory allocation on node number 2 from 23 to 34%. We decreased the overload situation from node number 3 from 55 down to 47%. And we also decreased the memory allocation for node number 4 from 48% down to 36%. And of course, as we decreased on the previous nodes, we need to have one node where we have an increased allocation of memory, which is node number 5 in that sense, where we came from an allocation of 3% and it moved up to 80%. So the positive information out of this first reorg run, we're capable with the initial run to already reduce the memory allocation below 50% as we had certain overload situations in the initial and actual status of the system. So first milestone has been reached already, so we're capable to reduce and not overload the certain nodes, but we're still, up in the 48%, so we're pretty close to 50% allocation. So we'd like to find out what are the options to further optimize the system. So let's close down the simulation and go back to configuration to adjust the configuration for the system we worked on before. We switch to make editable. And as a good hint, what we analyzed within system landscape before, we saw that the majority of the memory allocation is related to objects assigned to the group type SAP-BW.DSO. And as we are not focusing on a certain DSO at the moment or advanced DSO, we just take the selection on the schema and the group type as the one we'd like to first optimize on. Having said that, we're going to change the default configuration of the selection by schema and group type, and therefore we're going to add the option for maximum splits up to 6. We keep the location group as slave nodes, but we further consider level 2 partition sizes and also allow DDO to generate more table partitions than available hosts on the scale-out system. We're going to update this record, scroll up, activate the configuration, switch to redistribution, and kick off another plan generation activity. We're using the same profile as before, selecting the customer, configuration, selecting the database schema we used before, and leave anything else unchanged, and go for another plan generation. Again, this is the indicator for the plan generation, and we let the system execute and optimize the reorg plan, and let's wait for the plan being completed. The reorg plan successfully completed, and the plan 109 has been generated. Let's go ahead and select the plan and see on how the certain changes to the table placement configuration would have caused the system to balance the scale-out memory allocation in a more efficient way. If we select the screen and move down to the plan step section, we see that the table has been proposed to be altered from a #1 partitioning spec to a #6 partitioning spec, like more partitions being created than hosts available. And you see the relevant partitions to be created and assigned to the different hosts. This goes on and on for all the relevant tables. And of course, we're not focusing only on the DSO objects here, but due to the fact that those tables are the one identified to get the most potential out of the optimization, those DSO objects or advanced DSO objects are listed first in the plan steps. So plan has been selected. Let's take the simulation option to really get an idea on what's the optimization we achieve with this simple adoption of the table placement configuration. So again, we have the 6 nodes. The master node is pretty much unchanged because we have the row store tables already located on the master node. But then based on the current setting, the allocation of memory on the first node went down from 53 to 38. On the second node, it went up from 23 to 36, which is already in the range of being kind of balanced equally. On node number 3, we went down from 55 to 40%. Node number 4, 48 down to 34. And on node number 5, we have an increase from 3% up to 33%. So having said that, this is already a way better balancing compared to the initial balancing we generated. For this moment, I'm satisfied with the distribution plan. So what I'd like to do, I'd like to close down and take the next activity to finally execute those generated reorg steps. As I mentioned before, the system I'm demoing today is a system which has been installed using the remote deployment mode. So we were importing system data from a remote system. So in that case, the execute button is not active because we don't have the real data allocated to the system. In case we would have DDO installed on the real system, we would be in a position right now to select the plan being generated before and finally just execute the step. With an execution, this could be a scheduled execution, so you can take some low system activity period and execute the steps being generated. In this environment, as we using DDO in the remote deployment mode, it's required to export the relevant reorg steps and import it into your real system, and then finally execute the pre-generated reorg steps within HANA Studio Optimized Table Distribution. For that, we have an export button in here. So we are exporting the reorg steps assigned and calculated to the plan being generated before. If you open up the file, you'll see the same reorg steps also visible in the tab I showed you before. And you can take this file take it, copy it to your real system, and import it to your real system, and then use HANA Studio Optimized Table Distribution to execute the steps listed in here. Having said that, I'd like to thank you for watching this video. Goodbye.